Okay, in this example, we are going to prove the divisibility of some expression by using mathematical induction. We would like to show that 23 to the power n minus 1 is divisible by 11 for all natural numbers n. Let's get some idea about the statement. When n equal to 1, P1 is the statement that 23 to the power 1 minus 1 is divisible by 11. And it is true since it equals to 22, which is 11 times 2. How about n equal to 2? The statement P2 means 23 to the power 2 minus 1 is divisible by 11. And again, it is true since it equals to 528, which is 11 times 48. Now, you may wonder if it is true in general, right? So let's try to prove it by using mathematical induction. The first part is showing that P1 is true, but it is exactly what we did here. So the next step is the inductive step. Let's try to assume that Pk is true for some natural number k, which means that 23 to the power k minus 1 is divisible by 11. And it just means that this expression equal to 11 times m for some integer m. And it is exactly what divisibility means. Then we have to show that pk plus 1 is true, which means that 23 to the power k plus 1 minus 1 is divisible by 11. As you can see, for the power is k plus 1. Then how do we make use of the induction assumption? The trick is the following. We try to rewrite this guy to be 23 times 23 to the power k as here. And you will see 23 to the power k. Then we try to rewrite this minus 1 to be minus 23 plus 22. So that if you try to look at the first two terms, there is a common factor, 23. You just take it out, then you will see the expression in the induction assumption. So now you can replace it by 11 times m, and after simplification, you see 11 times 23m plus 2. And you can see why we have to emphasize that m is an integer. Otherwise, we cannot conclude that 23m plus 2 is another integer, so that we cannot conclude this expression is divisible by 11. Now, pk plus 1 is true under the assumption that pk is true. By mathematical induction, the result follows, and it completes the proof.